Hi, I'm Max, an engineer on the SwiftUI team.
And I'm Jeremy, an engineer on the Swift Standard Libraries team.
We're both delighted to share how you can build rich text editing experiences using the power of SwiftUI
and attributed string.
Together with Jeremy's help, I'll cover all the important aspects of rich text experiences in SwiftUI. First, I'll discuss upgrading TextEditor to support rich text using attributed string. Then, I'll build custom controls, enhancing my editor with unique features. And finally, I'll create my own text formatting definition, so my editor and its contents always look great. Now, while maybe an engineer by day, I'm also a home cook on a mission to make the perfect croissant. So recently, I've been cooking up a little recipe editor to keep track of all my attempts. It has a list of recipes to the left, a text editor for editing the recipe text in the middle, and a list of ingredients in the inspector to the right. I'd love to make the most important parts of my recipe text stand out so I can easily catch them at a glance while cooking. Today, I'll make that possible by upgrading this editor to support rich text. Here's the editor view, implemented using SwiftUI's Text Editor API. As indicated by the type of my text state, string, it currently only supports plain text. I can just change string into attributed string, dramatically increasing the view's capabilities. Now that I have support for rich text, I can use the system UI for toggling boldness and applying all kinds of other formatting, such as increasing the font size. I can now also insert Gmemoji from the keyboard. And thanks to the semantic nature of SwiftUI's font and color attributes, the new text editor can support dark mode and dynamic type as well. In fact, Text Editor supports boldness, italics, underline, strike-through, custom fonts, point size, foreground and background colors, kerning, tracking, baseline offset, Gmemoji, and important aspects of paragraph styling. Line height, text alignment, and base writing direction are available as separate, independent attributed string attributes for SwiftUI as well. All these attributes are consistent with SwiftUI's non-editable text, so you can just take the content of a text editor and display it with text later. Just like with text, Text Editor substitutes the default value calculated from the environment for any attributed string keys with a value of nil. Jeremy, I gotta be honest here. I've managed my way through working with attributed strings so far, but I could really use a refresher to make sure all my knowledge is super solid before I get into building controls. Also, I really gotta make that croissant dough for later, so would you mind sharing a refresher while I do that?
Sure thing, Max. While you get started on preparing the croissant dough, I'll take a moment to discuss some attributed string basics that will come in handy when working with rich text editors. In short, attributed strings contain a sequence of characters and a sequence of attribute runs. For example, this attributed string stores the text, "Hello, who's ready to get cooking?" It also has 3 attribute runs: a starting run with just a font, a run with an additional foreground color applied, and a final run with just the font attribute. The attributed string type fits right in alongside other Swift types you use throughout your apps. It's a value type, and just like string from the standard library, it stores its contents using the UTF-8 encoding. Attributed string also provides conformances to many common Swift protocols, such as equatable, hashable, codable, and sendable. The Apple SDKs ship with a variety of predefined attributes, like those Max shared earlier, grouped into attribute scopes. Attributed string also supports custom attributes that you define in your app for styling personalized to your UI. I'll create my attributed string from earlier using a few lines of code. First, I create an attributed string with the start of my text. Next, I create the string cooking, set its foreground color to orange, and append it to the text. Then I complete the sentence with the ending question mark. Lastly, I set the entire text's font to the large title font. Now I'm ready to display it in my UI on my device. For more on the basics of creating attributed strings, as well as creating and using your own custom attributes and attribute scopes, check out the What's New in Foundation session from WWDC 2021. Max, it looks like you're done making the dough. Are you ready to dive into the details of using attributed string in your recipe app?
For sure, Jeremy. That sounds like just what I needed. I've really been wanting to offer better controls connecting my text editor to the rest of my app. I want to build a button that allows me to add ingredients to the list in the inspector to the right, but without having to type out the name of the ingredient manually again. For example, I just want to be able to select the word butter that is already in my recipe and mark it as an ingredient with a single press of a button. My inspector already defines a preference key that I can use in my editor to suggest a new ingredient for the list. The value I pass to the preference view modifier will bubble up the view hierarchy and can be read via the name new ingredient preference key by any view that uses my recipe editor. Let me define a computed property for this value below my view body. All I need to provide for the suggestion is the name as an attributed string. Of course, I don't just want to suggest the entire text that is in my editor. Instead, I want to suggest the text that is currently selected, like I showed with butter. TextEditor communicates what is selected via the optional selection argument. Let me bind that to a local state of type attributed text selection. Okay, now that I have all the context I need available in my view, let me head back to the property computing the ingredient suggestion. Now I need to get the text that is selected. Let me try subscripting text with the result of this indices function on selection. That does not seem to be the right type. It returns attributed text selection.indices. Let me look that up. Oh, that is interesting. I just have one selection, but the indices type second case is represented by a set of ranges. Jeremy, can you explain why that is while I get to folding my croissant dough?
That's funny. I'm also folding, under the anticipation of these tasty croissants. But no worries, Max. I'll explain why this API doesn't use the range type you expected. To explain why this API uses a range set and not a single range, I'll dive in to attributed string selections. I'll discuss how multiple ranges can form selections and demonstrate how to use range sets in your code. You've likely used a single range in attributed string APIs or other collection APIs before. A single range allows you to slice a portion of an attributed string and perform an action over that single chunk. For example, attributed string provides APIs that allow you to quickly apply an attribute to a portion of text all at once. I've used the range of API to find the range of the text cooking in my attributed string. Next, I use the subscript operator to slice the attributed string with that range to make the entire word cooking orange. However, an attributed string sliced with just one range isn't enough to represent selections in a text editor that works for all languages. For example, I might use this recipe app to store my recipe for soufganiot that I plan to cook during the holidays, which includes some Hebrew text. My recipe says to put the soufganiot in the pan, which uses English text for the instructions and Hebrew text for the traditional name of the food. In the text editor, I'll select a portion of the word soufganiot and the word in with just one selection. However, this is actually multiple ranges in the attributed string. Since English is a left-to-right language, the editor lays out the sentence visually from the left side to the right side. However, the Hebrew portion, soufganiot, is laid out in the opposite direction, since Hebrew is a right-to-left language. While the bidirectional nature of this text affects the visual layout on the screen, the attributed string still stores all text in a consistent ordering. This ordering breaks apart my selection into two ranges: the start of the word sufganiot and the word in, excluding the end of the Hebrew text. This is why the SwiftUI text selection type uses multiple ranges rather than a single range. To learn more about localizing your app for bidirectional text, check out the Get It Right to Left session from WWDC25 and this year's Enhance Your App's Multilingual Experience session. To support these types of selections, attributed string supports slicing with a range set, the type Max noticed in the selection API. Just like you can slice an attributed string with a singular range, you can also slice it with a range set to produce a discontiguous substring. In this case, I've created a range set using the indices where function on the character view to find all uppercase characters in my text. Setting the foreground color to blue on this slice will make all uppercase characters blue, leaving the other characters unmodified. SwiftUI also provides an equivalent subscript that slices an attributed string with a selection directly. Hey Max, if you finished folding that beautiful croissant dough, I think using the subscript API that takes a selection might resolve the build error in your code.
Let me give that a try. I can just subscript text with the selection directly, and then transform the discontiguous attributed substring into a new attributed string. That's awesome. Now, when I run this on device and select the word butter, SwiftUI automatically calls my property NewIngredientSuggestion to compute the new value, which bubbles up to the rest of my app. My inspector then automatically adds the suggestion at the bottom of the ingredient list. From there, I can commit it to the ingredient list with a single tap. Features like that can elevate an editor to a beautiful experience. I'm really happy with this addition. But with everything Jeremy has shown me so far, I think I can go even further. I want to better visualize the ingredients in the text itself. The first thing I need for that is a custom attribute that marks a range of text as an ingredient. Let me define this in a new file. This attribute's value will be the ID of the ingredient it refers to. Now I'll head back to the property computing the ingredient suggestion in the recipe editor file. Ingredient suggestion allows me to provide a closure as a second argument. This closure gets called when I press the plus button and the ingredient is added to the list. I will use that closure to mutate the editor text, marking up occurrences of the name with my ingredient attribute. I get the ID of the newly created ingredient passed into the closure. Next, I need to find all the occurrences of the suggested ingredient name in my text. I can do this by calling rangeSoff on attributed strings characters view. Now that I have the ranges, I can just update the value of my ingredient attribute for each range. Here, I'm using a short name for the ingredient attribute I had already defined. Let's give it a try. I don't expect anything new here. After all, my custom attribute doesn't have any formatting associated with it. Let me select yeast and press the plus button. Wait, what was that? My cursor was at the top, not at the end. Let me try again. I select salt. I press the plus button, and my selection jumps to the end. Jeremy, I have to roll out my croissant dough, so I can't debug this right now. Do you know why my selection is getting reset?
That's definitely not an experience we want for the cooks using your app. Why don't you get started on rolling out the dough, and I'll dive into this unexpected behavior. In order to demonstrate what's happening here and how to fix it, I'll explain the details of attributed string indices, which form the ranges and text selections used by Rich Text Editor. AttributedString.index represents a single location within your text. To support its powerful and performant design, attributed string stores its contents in a tree structure, and its indices store paths through that tree. Since these indices form the building blocks of text selections in SwiftUI, the unexpected selection behavior in the app stems from how attributed string indices behave within these trees. You should keep 2 key points in mind when working with attributed string indices. First, any mutation to an attributed string invalidates all of its indices, even those not within the bounds of the mutation. Recipes never turn out well when you use expired ingredients, and I can assure you that you'll feel the same way about using old indices with an attributed string. Second, you should only use indices with the attributed string from which they were created. Now, I'll explore indices from the example attributed string I created earlier to explain how they work. Like I mentioned, attributed string stores its contents in a tree structure, and here I have a simplified example of that tree. Using a tree allows for better performance and avoids copying lots of data when mutating your text. AttributedString.index references text by storing a path through the tree to the referenced location. This stored path allows attributed string to quickly locate specific text from an index. But it also means that the index contains information about the layout of the entire attributed string's tree. When you mutate an attributed string, it might adjust the layout of the tree. This invalidates any previously recorded paths, even if the destination of that index still exists within the text. Additionally, even if 2 attributed strings have the same text and attribute content, their trees may have different layouts, making their indices incompatible with each other. Using an index to traverse these trees to find information requires using the index within one of attributed string's views. While indices are specific to a particular attributed string, you can use them in any view from that string. Foundation provides views over the characters or grapheme clusters of the text content, the individual Unicode scalars that make up each character, and the attribute runs of the string. To learn more about the differences between the character and Unicode scalar views, check out Apple's developer documentation for the Swift character type. You might also want to access lower-level contents when interfacing with other string-like types that don't use Swift's character type, such as NSString. Attributed string now also provides views into both the UTF-8 scalars and the UTF-16 scalars of the text. These 2 views still share the same indices as all of the existing views. Now that I've discussed the details of indices and selections, I'll revisit the problem that Max encountered with the recipe app. The onApply closure in the ingredient suggestion mutates the attributed string, but it doesn't update the indices in the selection. SwiftUI detects that these indices are no longer valid and moves the selection to the end of the text to prevent the app from crashing. To fix this, use attributed string APIs to update your indices and selections when mutating text. Here, I have a simplified example of code that has the same problem as the recipe app. First, I find the range of the word cooking in my text. Then, I set the range of cooking to an orange foreground color. And I also insert the word chef into my string to add some more recipe theming. Mutating my text can change the layout of my attributed strings tree. Using the cooking range variable after I've mutated my string is not valid. It might even crash the app. Instead, attributed string provides a transform function, which takes a range, or an array of ranges, and a closure, which mutates the provided attributed string in place. At the end of the closure, the transform function will update your provided range with new indices to ensure you can correctly use the range in the resulting attributed string. While the text may have shifted in the attributed string, the range still points to the same semantic location. in this case, the word cooking. SwiftUI also provides an equivalent function that updates a selection instead of a range. Wow, Max, those croissants are really shaping up great. If you're ready to dive back into your app, I think using this new transform function will help get your code into shape too.
Thank you. That sounds like just what I was looking for. Let me see if I can apply this in code. First, I shouldn't loop over the ranges like that. By the time I reach the last range, the text has been mutated many times, and the indices are outdated. I can avoid the problem entirely by first converting my ranges to a range set. Then I can just slice with that and remove the loop. This way, everything is one change, and I don't need to update the remaining ranges after each mutation. Second, next to the ranges I want to change, there is also the selection representing my cursor position. I need to always make sure it matches the transformed text. I can do that using SwiftUI's transform updating overload on attributed string. Nice. Now my selection is updated right as the text gets mutated. Let's see if that worked. I can select milk, it appears in the list, and when I add it, my selection remains intact. To double check, when I press Command B on the keyboard now, I can see the word milk turning bold, just as expected. Now that I have all the information in my recipe text, I want to emphasize the ingredients with some color. Thankfully, TextEditor provides a tool for that, the Attributed Text Formatting Definition protocol. A custom text formatting definition is all structured around which attributed string keys your text editor responds to and what values they might have. I already declared a type conforming to the Attributed Text Formatting Definition protocol here. By default, the system uses the SwiftUI attribute scope, with no constraints on the attribute's values. In the scope for my recipe editor, I only want to allow foreground color, Genmoji, and my custom ingredient attribute. Back on my recipe editor, I can use the Attributed Text Formatting Definition modifier to pass my custom definition to SwiftUI's text editor. With this change, my text editor will allow any ingredient, any Genmoji, and any foreground color. All of the other attributes now will assume their default value. Note that you can still change the default value for the entire editor by modifying the environment. Based on this change, TextEditor has already made some important changes to the system formatting UI. It no longer offers controls for changing the alignment, the line height, or font properties, since the respective attributed string keys are not in my scope. However, I can still use the color control to apply arbitrary colors to my text, even if those colors don't necessarily make sense. Oh no, the milk is gone. I really only want ingredients to be highlighted green, and everything else to use the default color. I can use SwiftUI's Attributed Text Value Constraint protocol to implement this logic. Let me head back to the recipe formatting definition file and declare the constraint. To conform to the Attributed Text Value Constraint protocol, I first specify the scope of the attributed text formatting definition it belongs to, and then the attributed string key I want to constrain, in my case, the foreground color attribute. The actual logic for constraining the attribute lives in the constrain function. In that function, I set the value of the attribute key, the foreground color, to what I consider valid. In my case, the logic all depends on whether the ingredient attribute is set. If so, the foreground color should be green. Otherwise, it should be nil. This indicates TextEditor should substitute the default color. Now that I have defined the constraint, I just need to add it to the body of the attributed text formatting definition. From here, SwiftUI takes care of all the rest. TextEditor automatically applies the definition and its constraints to any part of the text before it appears on screen. All the ingredients are green now. Interestingly, TextEditor has disabled its color control, despite foreground color being in my formatting definition scope. This makes sense considering the ingredients are green constraint I added. The foreground color now solely depends on whether text is marked with the ingredient attribute. TextEditor automatically probes attributed text value constraints to determine if a potential change is valid for the current selection. For example, I could try to set the foreground color of milk to white again. Running my ingredients are green constraint afterwards would change the foreground color back to green. So TextEditor knows this is not a valid change and disables the control. My value constraint will also be applied to text I paste into my editor. When I copy an ingredient using Command-C and paste it again using Command-V, my custom ingredient attribute is preserved. With codable attributed string keys, this can even work across text editors in different apps, as long as both apps list the attribute in their attributed text formatting definition. This is pretty great, but there are still some things to improve. With my cursor at the end of the ingredient milk, I can delete characters or continue typing, and it just behaves like regular text. This makes it feel like it is just green text and not an ingredient with a certain name. To make this feel right, I want the ingredient attribute not to expand as I type at the end of its run. And I would like the foreground color to reset for the entire word at once if I modify it. Jeremy, if I promise I'll give you an extra croissant later, will you help me getting that implemented?
I'm not sure one's going to be enough, but make it a few and you've got a deal, Max. While you go get those croissants in the oven, I'll help explain what APIs might help with this problem. With the formatting definition constraints that Max demonstrated, you can constrain which attributes and which specific values each text editor can display. To help with this new issue with the recipe editor, the attributed string key protocol provides additional APIs to constrain how attribute values are mutated across changes to any attributed string. When attributes declare constraints, attributed string always keeps the attributes consistent with each other and the text content to avoid unexpected state with simpler and more performant code. I'll dive into a few examples to explain when you might use these APIs for your attributes. First, I'll discuss attributes whose values are coupled with other content in the attributed string, such as a spell-checking attribute. Here, I have a spell-checking attribute that indicates the word ready is misspelled via a dashed red underline. After performing spell-checking on my text, I need to make sure that the spell-checking attribute remains only applied to the text that I have already validated. However, if I continue typing in my text editor, by default, all attributes of the existing text are inherited by inserted text. This isn't what I want for a spell-checking attribute, so I'll add a new property to my attributed string key to correct this. By declaring an inherited by added text property on my attributed string key type with a value of false, any added text will not inherit this attribute value. Now, when adding new text to my string, the new text will not contain the spell-checking attribute, since I have not yet checked the spelling of those words. Unfortunately, I found another issue with this attribute. Now, when I add text to the middle of a word that was marked as misspelled, the attribute shows an awkward break in the red line underneath the added text. Since my app hasn't checked if this word is misspelled yet, what I really want is for the attribute to be removed from this word to avoid stale information in my UI. To fix this problem, I'll add another property to my attributed string key type, the invalidation conditions property. This property declares situations when a run of this attribute should be removed from the text. Attributed string provides conditions for when the text changes and when specific attributes change, and attribute keys can invalidate upon any number of conditions. In this case, I need to remove this attribute whenever the text of the attribute run changes, so I'll use the text changed value. Now, inserting text into the middle of an attribute run will invalidate the attribute across the entire run, ensuring that I avoid this inconsistent state in my UI. I think both of those APIs might help keep the ingredient attribute valid in Max's app. While Max is finishing up with the oven, I'll demonstrate one more category of attributes. Attributes that require consistent values across sections of text. For example, a paragraph alignment attribute. I can apply different alignments to each paragraph in my text. However, just a single word cannot use a different alignment than the rest of the paragraph. To enforce this requirement during attributed string mutations, I'll declare a run boundaries property on my attributed string key type. Foundation supports limiting run boundaries to paragraph edges or the edges of a specified character. In this case, I'll define this attribute as constrained to paragraph boundaries to require that it has a consistent value from the start to the end of a paragraph. Now, this situation becomes impossible. If I apply a left alignment value to just one word in a paragraph, attributed string automatically expands the attribute to the entire range of the paragraph. Additionally, when I enumerate the alignment attribute, attributed string enumerates each individual paragraph, even if two consecutive paragraphs contain the same attribute value. Other run boundaries behave the same. Attributed string expands values from one boundary to the next and ensures enumerated runs break on every run boundary. Wow, Max, those croissants smell delicious. If the croissants are all set in the oven, do you think some of these APIs might complement your formatting definition to achieve the behavior you want for your custom attribute?
That sounds like just the secret ingredient I needed. The croissants are all set in the oven, so I can try this out right away. In my custom ingredient attribute here, I will implement the optional inherited by added text requirement to have the value false. That way, if I type after an ingredient, it won't expand. Second, let me implement invalidation conditions with text changed. So when I delete characters in an ingredient, it will no longer be recognized. Let's give it a try. When I add a Y at the end of milk, the Y is no longer green. And when I delete a character off milk, the ingredient attribute gets removed from the entire word at once. Based on my attributed text formatting definition, the foreground color attribute continues to follow my custom ingredient attribute's behavior perfectly. Thank you, Jeremy. This app really turned out great.
No problem. Now, about those croissants that you promised.
Don't worry, they're almost ready. Why don't you guard the oven though, since I'm slightly worried Luca might steal them away from us.
Ah, the Luca. I've heard of him. Lover of all things widgets and croissants. I'm on it, chef.
Now, before I go join Jeremy, let me give you some final tips. You can download my app as a sample project, where you can learn more about using SwiftUI's transferable wrapper for lossless drag and drop or export to RTFD, and persisting attributed string with Swift data. Attributed string is part of Swift's open source foundation project. Find its implementation on GitHub to contribute to its evolution, or get in touch with the community on the Swift forums. With the new text editor, it has also never been easier to add support for Gmoji input into your app, so consider doing that now. I just can't wait to see how you will use this API to upgrade text editing in your apps. Just a little sprinkle can make it pop.
So delicious.
No, So rich.